Welcome to Relearn. A number line is a straight line that visually represents numbers placed sequentially and at equal distances. It extends infinitely in both directions, shown by arrow sign on both sides of line. There are infinite numbers on number line. Number systems use symbols to represent numbers. The decimal system, base 10, uses digits 0 to 9. Other systems include binary base 2, using 0 and 1, and hexadecimal base 16, using 0 to 9 and AF, though they're not covered here. You can perform arithmetic operations in number line. Comparison. Numbers on left are smaller than numbers on right. Addition. Move right by the number of steps equal to the second number. Example 3 plus 2. Jump to right 2 steps from 3. Subtraction. Move left by the number of steps equal to the second number. Example 3 minus 2. Jump 2 steps to left from 3. Multiplication. Start at 0 and jump to the right by the first number steps, repeated the second number of times, for example 2 multiplied by 3. Start at 0, jump 2 steps to the right, 3 times. Division. Jump left by the divisor steps until you reach 0. For example 6 divided by 3. Start at 6 and jump 3 steps left until you reach 0. The number of jumps is the quotient. Numbers are divided into following types. Real numbers, all numbers that can be represented on a number line. This includes whole numbers, integers, fractions, and decimals, both positive and negative. Essentially, any number you can think of, except for imaginary numbers, like the square root of -1, is a real number. Natural numbers, numbers that start at 1 and go on forever, such as 3, 6, 57, 973, and 4000. Whole numbers, numbers that include all natural numbers and 0, such as 1, 2, 3, 4, and so on. Integers, all negative and positive whole numbers, and 0. Rational numbers, numbers that can be written as a fraction, p over q, where q is not equal to 0. Irrational numbers, numbers that cannot be written as a fraction, p over q, where p, q are integers and q is not equal to 0, such as non-terminating decimals, non-repeating decimals, and infinite numbers like pi. Prime numbers. A prime number is a natural number greater than 1 that has no positive divisors other than 1 and itself. Prime numbers are fundamental in mathematics because they cannot be formed by multiplying to smaller natural numbers. For example, 5 is a prime number because it can only be divided by 1 and 5 without leaving a remainder. Prime numbers are the building blocks of all natural numbers since every natural number can be factored into primes, known as its prime factorization. This property makes them crucial in various fields, including cryptography and number theory. Composite numbers, numbers that have more than 2 factors, such as numbers that are divisible by a number other than 1 and the number itself. Order of operations. BODMAS. Arithmetic operations are performed in the following order. 1. Bracket. 2. Order like square, cube. 3. Division. 4. Multiplication. 5. Addition. 6. Subtraction. Key properties of numbers. Commutative property. Order doesn't matter. A plus B is equal to B plus A. Associative property. Grouping doesn't matter. A plus B plus C is equal to A plus B plus C. Distributive property. Multiplication distributes over addition. A multiplied by B plus C is equal to A multiplied by B plus A multiplied by C. Identity property. Adding 0 or multiplying by 1 leaves a number unchanged. A plus 0 is equal to A. A times 1 is equal to A. Inverse property. Adding the opposite or multiplying by the reciprocal yields the identity A plus minus A is equal to 0. Closure property. Operations on numbers in a set produce results in the same set. Example, integers stay integers when added. Reflexive property. A number equals itself. A is equal to A. Symmetric property. If A is equal to B, then B is equal to A. Transitive property. If A is equal to B and B is equal to C, then A is equal to C. Properties of integers. Closure property. Integers are closed under addition, subtraction, and multiplication, but not under division. For example, 1 divided by 2 is equal to 0.5, which is not an integer. Commutative property. True for addition and multiplication but not subtraction or division. For example, 5 minus 3 is not equal to 3 minus 5. Associative property. True for addition and multiplication but not subtraction or division. 10 minus 5 minus 2 is not equal to 10 minus 5 minus 2. Distributive property. A times B plus C is equal to A times B plus A times C. Properties of whole numbers. Closure property. Whole numbers are closed under addition, subtraction, and multiplication, but not under division. Commutative property. True for addition and multiplication but not subtraction or division. 5 minus 3 is not equal to 3 minus 5. Associative property. True for addition and multiplication but not subtraction or division. 10 minus 5 minus 2 is not equal to 10 minus 5 minus 2. Distributive property. A times B plus C is equal to A times B plus A times C. The decimal number system is a base 10 numbering system that uses 10 digits, 0 to 9, to represent numbers, with each digit's value depending on its position or place value. It is the most widely used system for arithmetic and everyday counting. Euclid's division lemma. It states that for any two positive integers a and b, there exist unique integers q, quotient, and r, remainder, such that a is equal to b q plus r, where 0 less than or equal to r and r is less than b. In simpler terms, when you divide one number, a, the dividend, by another, b, the divisor, you get a quotient, q, and a remainder, r. The remainder will always be a non-negative number smaller than the divisor. Example: if you divide 25 by 7, 25, dividend, is equal to 7, divisor, times 3, quotient, plus 4, remainder. In this case, a is equal to 25, b is equal to 7, q is equal to 3, and r is equal to 4. The remainder, 4, is less than the divisor, 7, and the conditions of the lemma are met. Key points. Uniqueness. For a given pair of integers a and b, the quotient q and remainder r are unique. Remainder's range. The remainder, r, can be 0, but it will always be less than the divisor, b. Fundamental theorem of arithmetic. Every integer greater than 1 is either a prime number or can be expressed as unique product of prime numbers. Least common multiple, LCM. The LCM of two or more numbers is the smallest number that is a multiple of all of them. LCM of numbers can be calculated using following methods. 1. LCM by listing method. 2. LCM by prime factorization. 3. LCM by division method. Example: LCM of 4 and 5. 1. Find first few multiples of 4. They are 4, 8, 12, 16, 20, 24. 2. Find first few multiples of 5. They are 5, 10, 15, 20, 25. 3. Mark common multiples. They are 20 and 40. Select smallest, so 20 is LCM of 4 and 5. Highest common factor, HCF. The HCF of two or more numbers is the largest number that divides all of them without leaving a remainder. HCF of 12 and 18 can be found by listing common factors. Factors of 12 are 1, 2, 3, 4, 6, 12. Factors of 18 are 1, 2, 3, 6, 9, 18. Highest common factor to both is 6.